Hey everyone, today we're talking a little bit about displays. More specifically, we're going to be discussing text displays, but I guess I want to start with using redstone lamps. You see, redstone lamps are by far the most common type of display, and that's for good reason. The reason this is the case is because, well, they're kind of basically designed for that almost. They're incredibly fast, reliable, always work when you want them to, and they're incredibly intuitive. All you have to do is just apply a redstone power source. This means that for any computer, screen, or really just any sort of display, the hardware is pretty trivial. You just need a flat panel of redstone lamps, and some kind of wiring system to hook it all up. And I understand that there's obviously a bunch more nuance with how you wire things up to make sure everything works. I mean, I clearly don't know anything about that. I've just pasted in a bunch of wool and random wires. But basically the big idea is when you want to display something, you go with redstone lamps. Yet, they unfortunately come with one fatal flaw, and it's that they're just absolutely hideous. The reality is that when you take any sort of repeating pattern complexity like this and tile it over a large plane, it starts to get really ugly, combined with the sort of brown colors not very contrasting well against the bright yellow spots that are created by the on lamps. It's just generally a very unpleasant thing to look at. There are plenty of ways to actually remedy this problem, whether it's using a panel of tinted glass to increase the contrast, or actually using a texture pack to make these pixels black and these pixels perfect white. But overall, as a whole, the redstone lamp is just not the best looking display block. Now that my harsh criticism of the redstone lamp display is over, it's time to do the most squibble thing ever and provide a solution that definitely can't replace it. And when I say that, I completely mean it, because this thing is clunky, slow, humongous, can only display text and eats up about half the server's performance, and today's video is going to be about how I built it and why. I guess I should start with the idea. The thing that inspired me the most is probably this split flap display, and the reason why I thought it was so cool was because it allows you to display text or font with essentially any resolution. The fact that we just have literal flaps covered in paint allows us to essentially make any sort of specificity we want without being hindered with hardware limitations. Now unfortunately, due to the very clever design of it, we're not going to be able to accomplish anything like this in Minecraft, but the thing is we have something close. We have piston feed tapes. Now it's not like feed tapes are specifically a Minecraft concept. I mean, people have been using tapes for about a century to store information. And this is because they're super compact. I mean, you just have a roll of some kind of film or something, and this allows you to store insane amounts of information densely stacked together. Now unfortunately in Minecraft we don't have this luxury, because the reality is that any tape we're going to be working with is going to be inherently 1 meter thick due to the fact that our blocks are 1 meter thick. However, despite us losing out on the main benefit of anything tape related, we still do get something super important, and it's that it is a physical display. It doesn't use lamps or anything like that, meaning we can literally build whatever we want, allowing us to access incredibly cool character designs made from complex things like slabs, stairs, and basically anything you can imagine into a 4x4 slice. We can put it onto a display and display it in a string of text. One of the biggest fall-offs of the redstone lamp display is we're confined to the 1x1 pixel grid that Minecraft gives us, whereas in here, we can use any amount of detail we'll like and it'll still come through perfectly clear without any level of added complexity. Okay, that's super cool and all, but where's the actual machine? Well, here's design iteration 1, and you might notice that it is quite large, and unfortunately this is not just a thing with design iteration 1, all of them are going to be absolutely huge. I had to unfortunately cope with the fact that this thing was inherently going to be ginormous due to the fact that each and every single character consisted of 5 pieces of feed tape. 4 for the text and 1 for including the black barrier that I'll get into in a little bit. But essentially what this means is that we have a really long feed tape here. In fact, we're storing 255 blocks. As for how this thing works, it's pretty straightforward. We just move the blocks in a simple bend. Some important details to consider is on the top here, we've actually got this super cool piston feed tape line extender, where essentially we use slime blocks that are pulling the sides of blocks to move blocks forward in a single line without ever having to introduce any bends. This is super useful for compacting the top section. As for down here, we have a really interesting sticky piston setup to very quickly remove this block from the front without actually having to intrude into this wall area where the front of the display would lie. The initial character set that we were going to use was all the letters, as you can see, A through Z, and then all the numbers, 0 through 9, as well as these extra symbols. The initial character set included 51 symbols and did not include these two symbols. The reason was because I actually miscounted originally. I was shooting for 50, but then I made a mistake, so then we ended up with 51, and I realized that it would actually be easier to ramp it up to 53 to clean up the design, than to refigure things out and remove exactly 5 blocks from the feed tape. Actually fine-tuning any of these machines to have exactly the number of blocks we need in our entire feed tape was actually quite difficult, and this is super important because if there's ever a gap anywhere, we're going to need to account for that in our logic later, which is kind of not something I really want to do. Then it was just a bunch of fixing errors, making sure everything's ready, trying to prevent traffic jams like down here, figuring out just exactly how fast we can clock this thing before it starts to break, and now we're on to the worst part of basically any project like this: tileability. Since we're very, very deeply missing the mark on every single category when it comes to efficiency, we need to make sure that we make up for it in the one category we can do right, and that's making it look good. And making it look good means we have exactly one block of space between every single character. This is non-negotiable. This is a design constraint I absolutely have to roll with, otherwise this thing's going to be a massive disappointment. That means that every single module is only 5 blocks wide, and since 4 blocks of that is consumed by basically exclusively feed tape, we'll only have a single line of blocks to run an entire wiring system to hook up the entire feed tape, and it all has to function independently. That means no cross-interference between any given module. I'm really going to skim through this phase of the design process because it was kind of boring, but mainly we'd encounter mistakes like this one. You see, here I actually chose to save out on a rail here by putting a block here instead. What that actually does is it quasi-powers the next slice over, and this was originally unnoticeable until I clocked them at different speeds, and this just happened at just the right moment such that this piston just happens to be updated at the same time this fires, meaning that we're going to get some weird piston action, and this piston fires independently from all the rest, and everything essentially blows up. Anyways, after all that pain, we finally end up with a working design. And that is this one, and I can show you it tiles perfectly by running 3 completely unsynchronized displays, and they'll all cycle perfectly, even though it looks absolutely horrible that they're going at different speeds. Next, we kind of added the guts of the system. I'm not going to get into too much of the details of how the counting system works, mostly because it's really bad and could definitely be replaced with something that I'll discuss much later in the video. But essentially, this top circuit makes sure that it counts in intervals of 5, because we have 5 blocks per line. This bottom circuit contains all the information. If we want to select character 16, we put 16 items in here. And this bottom section stores the current state. Here we're at 0, which means this dropper is empty. And now we're going to be back in that world I showed you in the intro, because at this point in the project, I had enlisted the help of 2 of my fellow friends from WaveTech to help me on here, the WaveTech Creative Multiplayer server. Anyways, I want to say that if you're liking the video so far and you want to see other content like that, make sure to subscribe, check out the rest of my channel, and let's move on. Anyways, big thank you to Magic and JKM because they were a massive help in designing the water stream situation, as well as fixing the tons and tons of errors that were going on in this counting system. JKM also wrote a very nice little program that essentially allows you to take any string you write into it and directly convert it into the numbers required to encode the text that you actually want to display on this system. So what do we have now? We have a text display that can display virtually any string of text, basically in any kind of length, although the server's performance might be tanking, already at 20 characters we've got here. But there are a few problems. Namely, one of them is the system in which the number actually reads to the letter that we're looking for. The reality is that if we want to get from B to C, we actually have to loop the entire system over, and then we can arrive at C. This is due to the fact that the counting system needs to reset back to the initial value, A, before actually moving on. Now, this seemingly kind of flaw was actually a deliberate decision I made in order to simplify the counting system, because the reality is that figuring out how to get to the letter you want is a lot easier when you force the machine to reset to a known position, like A. However, if I do end up making a second video where I remaster everything, including the speed, wiring, and the counting system, that will be one of the highlights of how we improve the efficiency of the design overall. And then seemingly out of nowhere, another WaveTech friend contacts me and says they want to work on the project too, and that'll be Paradox42. And what we worked on was essentially these tiny little things. And what these things are essentially the decimal versions of what we designed over there. Only they're a fraction of the size, more than twice as fast, consume significantly less performance, and might actually have a practical use in an environment outside of just fooling around. I mean, seriously, even though we don't get the full 53 character spectrum, these things put the other design to shame. The way we put it together was so much faster with such an incredibly streamlined design that this thing runs eventually once every 8 game ticks or at a 2.5 blocks per second rate. These things are incredibly fast and tiny as hell. As well as us together working on the super simple feed tape layout that we designed here, Paradox also went on to create this thing. I honestly have no idea how it works, but it's a brilliant setup that allows you to essentially just go straight to exactly the number you're looking for, without having to go through any of that returning to a single state that you remember nonsense. What this means is that since we have an intuitive way of interfacing with it, as well as a bunch of other benefits such as a smaller size, actually good performance, and generally a still pleasing display, this thing could actually be used in storage systems, mob farms, or even more novelty things like calculators. I also wanted to briefly mention that we have a Discord server now, so if you want to drop in, check out some teasers, the latest videos, announcements, or just interact with the community and have a quick chat with me, make sure to stop by. Anyways, if you enjoyed the video, make sure to stay tuned for the possible part 2 where we remaster it and fix a lot of the design flaws that I intentionally introduced. And also check out my other content if you like the kind of stuff that I make, and I'll see you next time.